So here we are done with all the type of mixed problems that are actually related with finding out the solution of a quadratic equation using the factorization method, the quadratic formula, or by completing the square. Now we'll move on further and talk about the nature of the roots. What will be the nature of the roots of a quadratic equation? So this is actually a new topic, that is the nature of the roots. So let us suppose if we are starting with finding out the roots of a quadratic equation, so we can say if we just wanted to find out the roots of the quadratic equation, then we can find the roots with the help of a quadratic formula. And I hope you remember the formula or the quadratic formula. So this would be like of the form for the equation ax square plus bx plus c is equal to 0. The roots are x is equal to minus b plus minus square root b square minus 4ac divided by 2a, which is actually called as the quadratic formula, or we sometimes call it as a Sridharacharya formula as well, if b square minus 4ac is greater than is equal to 0. So we are already done with this concept that for any quadratic equation, if we just wanted to find out the roots of this quadratic equation, then we can find it using the quadratic formula, which is this, having the condition that the term which is under the square root, that is b square minus of 4ac, should always be greater than is equal to 0. Then we can find the real root, and if b square minus 4ac is less than 0, then the roots are not real. So actually we are done with this concept of how we can say about the roots are real and the roots are not real. So depending upon this b square minus 4ac, we have some of the notes that are related with it, and then we'll further talk about the nature of the roots. So first of all, we have a very special note which says that b square minus 4ac actually determines whether the roots are real or not, because if b square minus 4ac is greater than is equal to 0, then the roots are called as real, and if b square minus 4ac is less than 0, then the roots are called as not real, and we can also call them as imaginary roots. We can also call them as nothing but imaginary roots then we will have. Now furthermore, we have a very special name of this b square minus 4ac. Actually, b square minus 4ac is called as discriminant of a quadratic equation. This is called as discriminant of a quadratic equation ax square plus bx plus c is equal to 0, and we denote it by capital of D. So wherever we have a capital of D, it is definitely b square minus 4ac. So capital D is equal to b square minus of 4ac. So depending upon this capital D, that is b square minus 4ac, we will now find out what will be the nature of the roots of a quadratic equation. Now let's just move on and let's just talk about some of the cases. So case number 1 says that if the discriminant, that is D, which is equal to b square minus 4ac, is greater than 0. So this value D can be greater than 0, this value can be equal to 0, and this value can be less than 0. So we have basically 3 cases. So when discriminant is actually greater than 0, means b square minus 4ac is greater than 0, then we get 2 distinct real roots. So this is the nature of the roots. Always remember, whenever we just wanted to find out the roots of a quadratic equation, first of all we'll talk about its nature. That if discriminant, that is d is equal to b square minus 4ac, is comes out as to be greater than 0, then always remember it has 2 distinct real roots. What is the meaning of 2 distinct? Means 2 different real roots. And those 2 distinct real roots should be of the form minus b by 2a plus square root b square minus 4ac by 2a, and furthermore minus b by 2a minus of square root b square minus 4ac by 2a. So in place of b square minus 4ac, you can also write capital D. So this would be minus b by 2a plus capital D, square root of capital D by 2a. Furthermore, this can be written as square root of capital D divided by 2a. So always remember, whenever we have the discriminant is greater than 0, then we get the 2 distinct real roots, and these are the 2 distinct real roots. Now let's just talk about the case number 2. So case number 2 actually says if D is equal to 0, if D comes out to be is equal to 0, then remember we have two roots which are equal, then the two roots are equal. Always remember, whenever we have d as 0, then the two roots are equal to each other, because if we'll substitute discriminant, that is d is equal to 0 in the quadratic formula, then we will get the two roots as nothing but minus b by 2a or again minus b by 2a. So these are nothing but the two roots which are equal to each other whenever capital D comes out to be is equal to 0. So always remember the case number 2. Whenever capital D is equal to 0, then the two roots are equal and real. Always remember, the two roots are equal as well as they are real roots, So we can say at the end that whenever d is equal to 0, then the two roots are real and equal. Let's just talk about the case number 3. Case number 3 says that if d is less than 0, then the roots are not real at all. And then we will not further find the roots with the help of the formula. We just say that the roots are not real and then we are done with it. That's our answer. So always remember, for the case number 3, whenever d comes out to be less than 0, then we'll say the answer would be like the roots are not real. So that's it. We will not find the roots furthermore using the quadratic formula. So case number 3 is when d is less than 0, then the roots are not real. They are also called as imaginary roots. So always remember, we can say the roots are not real and we can also say the roots are imaginary. Now let's just talk about an example which is related with it. Let us suppose if I am saying find the discriminant of this particular quadratic equation and hence find the nature of the roots, which you have to find the nature of the roots. So let's just find out the discriminant. As we know that for any quadratic equation which is of the type ax square plus bx plus c is equal to 0, we can compare both of these equations. So we have, after comparison, a is 2, b is minus 4, c is 3. So let's just find the discriminant. So d is nothing but b square minus of 4ac. Let's just substitute all the values over here. This is minus 4 square minus 4, 2 into 3. So this is nothing but 16 minus of, further we have 4 into 3 is 12, 12 into 2 is 24. As you can see over here, we have the value of discriminant is 16 minus 24, which is actually minus of 8, and this is less than 0. D is less than 0. So whenever D is less than 0, then the roots are not real, or we can call them as nothing but the imaginary roots. So what will be the nature of the roots? Roots are not real. / they are imaginary. So this will be the answer for such type of a question whenever d comes out to be less than 0. So for this particular example, we can see first of all, if we just wanted to find out the roots of any particular quadratic equation, we have to check the value of capital D. If d comes out to be less than 0, it means the roots are not real and then we will not further find the roots. But if d comes out to be greater than is equal to 0, then using the concept of either factorization method, either using any type of method that we have done before, we can find the roots of a quadratic equation. So this is all about the example which is related with the nature of the roots.